Welcome to Math Practice. Today we are going to discuss Introduction to Euclid's Geometry from class 9. So watch the video till the end and subscribe to Math Practice. The history of geometry. A Greek mathematician Thales gave the first known proof in geometry. This proof was of the statement that a circle is bisected by its diameter. Thales' most famous pupil was Pythagoras, whom we know for the very famous Pythagoras theorem. Euclid 325 BCE to 265 BCE was a teacher of mathematics at Alexandria in Egypt, and he was the first Greek mathematician who initiated a new way of studying geometry, so it is known as the Euclid's approach to geometry. Here we have axioms or postulates that are assumptions which are obviously universal truths. They are not proved, they are assumptions which are not proved. Theorems are statements which are proved using definitions and axioms or previously proved statements and deductive reasoning. You need to remember the following Euclid's axioms. The first axiom says that things which are equal to the same thing are equal to one another. Second axiom, equals are added to equals, the wholes are equal. All these axioms are very obvious, so we just have to remember the statements. If equals are subtracted from equals, the remainders are equal. Fourth axiom, things which coincide with one another are equal to one another. Fifth, the whole is greater than the part. Sixth axiom, things which are double of the same things are equal to one another. Seventh, things which are halves of the same things are equal to one another. Again, remember the 5 important Euclid's postulates. First postulate says that a straight line may be drawn from any one point to any other point. It gives rise to axiom 5.1, which says that given two distinct points, there is a unique line that passes through them. Postulate 2, a terminated line can be produced indefinitely. In both directions, you can produce the line. Postulate 3, a circle can be drawn with any center and any radius. Postulate 4, all right angles are equal to one another. Postulate 5, it seems to be difficult, but it can be easily understood by the diagram. Postulate 5 says that if a straight line passing on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of the angles is less than two right angles. That means suppose you are having lines y and z and x passes through it. The two interior angles 1 and 2 are such that the sum of these two angles is less than the sum of two right angles. Then if these lines y and z are extended on the side of angles 1 and 2, then they will definitely meet at some point. Now the two equivalent versions of the Euclid's fifth postulate, they follow from the Euclid's fifth postulate. First one says that for every line L and for every point P not lying on L, there exists a unique line M passing through P and parallel to L. It is obvious from the diagram that L is any line, P is a point which is not on L, then a line M will pass through P such that L and M are parallel. Second one, two distinct intersecting lines cannot be parallel to the same line. Suppose you are having line L and M, then they cannot be parallel to a same particular line. L will be parallel to some other line and M will be parallel to some other lines. Let us see theorem 5.1. Two distinct lines cannot have more than one point in common. It is very obvious. Let us try to prove it. You have to prove that if there are two distinct lines, say L and M, then they cannot have more than one point of intersection. For example, let us assume that the two lines intersect in two distinct points P and Q. So, two lines both pass through two distinct points P and Q. But this assumption contradicts the axiom that only one line can pass through two distinct points. Here two lines pass through two distinct points, so it gives a contradiction. So our assumption is false. Our assumption that two lines can pass through two distinct points is false. Hence we can conclude that two distinct lines cannot have more than one point in common. In this chapter, objective questions can be asked. First one, the basic facts that are taken for granted without proof. Without proof, they are called axioms. Second, fill in the blank. The conclusions obtained from logical reasoning based on previously proved results and axioms. They constitute a statement, and what are they called? It is called a theorem. Third, two distinct points in a plane determine a unique line. For a unique line, you need at least two distinct points. Fourth one, two distinct lines in a plane cannot have more than one point in common. We have just now seen this. Fifth one, a line divides a plane into three parts. If you have a plane and if you have a line in it, then it divides into three parts: the line itself and the two half planes above and below the line. Sixth, how many least number of distinct points are required to determine a unique line? 2. Next one. How many lines can be drawn through a given point? If you have one point, infinitely many lines can be drawn through it. Two distinct planes can intersect in infinitely many points, but only in one line. Ninth one. How many least number of non-collinear points determine a unique plane? Non-collinear means they are not in the same line. So, at least you need 3 points which are non-collinear to determine a unique plane. True or false? A terminated line can be produced indefinitely on both the sides. It is true. You can produce a line on both the sides. True or false? If two circles are equal, then their radii are equal. This is also true by the Euclid's axioms. True or false? A segment has no length. That is false. A line segment always has a definite length. True or false? The ray AB is same as ray BA. That is false, because ray AB has the initial point A and the point B. From that you can extend the ray indefinitely. While for ray BA, the initial point is B and from the point A you can extend the ray indefinitely. 14th one, a segment has two end points. You can be asked to define the following terms. First one, plane. A plane is a flat surface on which geometric figures can be drawn. What is a point? A point is represented by a fine dot and it is dimensionless. Remember, a point does not have any dimension. Line. A collection of points which can be extended in both the direction. It has length but no breadth. So line is called a breadthless length. Parallel lines. Now suppose if you have to define parallel lines, first of all you need to define a line. Lines are parallel if they do not have any common point. That is, they will never intersect each other. Perpendicular lines. Perpendicular lines are those lines in a plane which intersect each other at right angles. Line segment. A line segment is a part of a line which has a definite length. So remember, line segment has definite length and it has two endpoints. Next definition. Radius of a circle. A radius of the circle is a line segment from any point on the circumference to the center of the circle. Square. A quadrilateral with 4 sides equal and all 4 angles are right angles. A question can be asked, does Euclid's fifth postulate imply the existence of parallel lines? Yes. Why? Because the fifth postulate implies that if the sum of the interior angles is equal to the sum of the right angles, the two lines will not meet each other at any point, hence making them parallel lines. Now try to understand this. The fifth postulate says that if the sum of the interior angles is less than the sum of the right angles, then they will intersect. So it also means that if the sum of the interior angles is equal to the sum of the right angles, then the two lines will not meet each other at any point. So they will be parallel lines. Next example. If a point C lies between 2 points A and B such that AC is equal to BC, then prove that AC is equal to half AB. Second part also prove that if point C is called the midpoint of line segment AB, then prove that every line segment has one and only one midpoint. Now for the first part, we are given that C lies between A and B and AC is equal to BC. Now we add AC on both the sides. So AC plus AC is equal to BC plus AC. You have the axioms that if equals are added to equals, the wholes are equal. So 2AC is equal to AB. Why AB? Because BC plus AC is AB. Hence AC will be equal to half AB. In the second part, we have to prove that every line segment has one and only one midpoint. So again, if possible, assume that line segment AB has two midpoints which are C and D. So by the first part, AC will be equal to half AB because C is the midpoint. Similarly, D is also the midpoint. So AD will be equal to half AB. Now subtracting AD minus BC, that means you are subtracting AC from AD, you get half AB minus half AB, which is 0. That means AD minus AC. But what is AD minus AC? It is CD. CD is equal to 0. Implies that C and D are the same points. Hence AB has one and only one midpoint. Now some assignment examples. If A, B and C are 3 points on a line and B lies between A and C, then prove that AB plus BC is equal to AC. You will be able to prove this using the axioms. Second, say true or false. If line segment AB is equal to PQ, PQ is equal to XY, then AB will also be equal to XY. It is true and you have to write by which axiom. In the figure given, if AC is equal to BD, then prove that AB is equal to CD. Now what you will do over here is, since AC is equal to BD is given, but you know AC is AB plus BC and BD is BC plus CD. So now just equating you will get the proof. Fourth one, why is the axiom phi? What is axiom phi? The whole is greater than the part, called the universal truth. Now to justify this, you just need to give any example where the whole is greater than the part. For example, suppose if you are having half of the pizza, then obviously the half of the pizza will be less than the whole pizza, or the whole pizza will be greater than the half pizza. Hope Euclid's geometry is clear. Please like and share the video and subscribe to Math Practice. Thank you.